Today, we're diving into a really fascinating study that kind of flips the script on how we think math should be taught. It really challenges this simple but powerful idea that there's one best way to teach every single student. So let's get into the data and see what it really tells us. You know that feeling when you're just staring at a page of equations and thinking, okay, but when am I ever actually going to use this? Well, you are definitely not alone. This feeling, this huge disconnect, is a major problem in math education, and it's exactly what researchers in Indonesia wanted to figure out. So what's the big problem here? Well, it's this massive gap between what the curriculum says should be happening and what's actually going on in the classroom. Students are supposed to be making all these connections in math, but in reality, their ability to do that is often, well, alarmingly low. So let's be clear about what we're talking about. The skill is called mathematical connection ability. This isn't just about getting the right answer on a test. Nope. It's about seeing how one math idea, say fractions, connects to another, like percentages, and how both of those connect to something real, like splitting a pizza with your friends. It's what makes math click. It's what makes it meaningful. And you know, there's a really good reason why so many kids struggle with this. The study points back to the work of the famous psychologist Jean Piaget. He found that young students are in what he called a concrete operational stage. All that means is that their brains are basically wired to learn by touching, holding, and moving real-world objects around, not by just looking at abstract symbols on a whiteboard. Okay, so if that's the problem, how do you fix it? How do you build that bridge? Well, this study looked at one very promising solution. It's called the Concrete Pictorial Abstract Approach, or CPA for short. And it's this really clever three-step method designed to walk students from the physical world into the world of pure math. Here's how it works. It's pretty simple. First up, the concrete stage. Here, students are physically using things, like blocks or beads, whatever, to get their hands on a concept. Then you move to the pictorial stage. Now they learn to draw pictures of those objects. And finally, you hit the abstract stage. This is where they connect their drawings to the actual numbers and symbols, like the plus or minus signs. See? Each step builds right on the last one. And I want to be clear, this is not some brand new, untested idea. The thinking behind it goes back for decades. This quote here really gets to the heart of it. The idea is that when you physically interact with stuff, the concept just sticks in your brain better. It makes it easier to remember and, crucially, to use it in a real-life situation. It's all based on some really solid educational theory. So with all that background, let's get to the experiment itself. Researchers in West Java set up this study to see if the CPA method actually worked better than the old-school way of teaching. But what they found, well, it was a lot more complicated and, honestly, way more interesting than just a simple yes or no. So the setup itself was pretty straightforward. They took 39 fifth graders and split them into two groups. One group, about 20 kids, got taught using this hands-on CPA approach. The other group, with 19 kids, learned with the more traditional methods you'd expect to see in a classroom. The goal was to test both groups before and after to see whose mathematical connection ability improved more. Simple enough, right? All right, now take a look at these first results. This chart shows the overall improvement for each group. And, they're almost identical. The CPA group scored a 0.738, and the conventional group scored a 0.735. I mean, that's basically a tie. So you'd think, okay, guess it doesn't really make a difference. Case closed, right? Well, not so fast. Because that one big overall number, it was hiding the real story. The researchers decided to slice the data up a different way. They broke the students down based on their prior math skills, high, middle, and low-achieving students. And this is where it gets really good. Okay, look at this. This table just lays it all out. For the high-ability students, CPA was a little bit better, no big deal. But then look at the middle and low groups. Whoa. For the low-ability students, the CPA method was a massive win. Their improvement score was nearly double the other group. But for the middle-ability students, the exact opposite happened. They actually did way better with the conventional method. So what on earth is going on here? Well, the answer, according to the researchers, boils down to just one thing: how the students themselves perceived what they were doing. Here's the breakdown. On one hand, you have the low-ability students. For them, the hands-on stuff was fantastic. They were excited, they were engaged, and they actually used the physical objects to build a real foundation of understanding. But on the other hand, the middle-ability students, they kind of felt like they were too good for it. They saw the hands-on materials not as a learning tool, but as just playing, and so they pretty much ignored them. This quote from the research paper just sums it up perfectly.
The exact same tool can be this incredible bridge to understanding, or it can just be a distracting toy. The difference isn't in the tool itself. It's all in the student's mindset and how they decide to use it.
So, what's the big takeaway from all of this? It's that there is no single best way to teach. It just doesn't exist. The CPA method was an absolute game changer for one group, and it kind of fell flat for another. It shows that great teaching isn't about finding some magic bullet method. It's about really understanding the students in the room and picking the right tool for the right person at the right time.
And that leaves us with this huge, really important question. In a world that loves standardized tests and one-size-fits-all lesson plans, this research is a powerful reminder to think differently. How do we build learning experiences that are flexible enough to actually meet every single student right where they are? That, right there, is the real puzzle we need to solve.